Page 378, and we're looking at class example number 2. So class example number 2 focuses on our difference of square method. Okay, so remember, this is the method that I said when we have two terms. You'll notice that in each one of them there are two terms. Okay, but you can't use this every single time. Like, it's not like given that if you have two terms you will be able to use difference of squares. Difference of squares has a very strict condition in which you can only use them. It's very easy to do it, but it has to follow with this particular method. So the words here, it says difference, and difference means subtraction of squares. So that means the terms have to be perfect squares. So if you cannot take a square root of them, you cannot do difference of squares. So if you notice this first one over here, it has to have a different sign in them. So it's subtraction. In fact, every single question here has a subtraction. So if it doesn't meet one of these two conditions, you cannot do difference of squares. So the first condition is being met in every example here. The second one is it has to be squares, meaning it has to be perfect square. Now if you notice, x squared is something that you can take a square root of. It will give you x. And if you take a square root of 49, it gives you 7. So if you can't do this, you cannot use difference of squares. So first example, obviously I can do that. And what that gives you is two factors. One is x minus 7. So you take those square roots. And the other one is x plus 7. Now, why does this work? Just to kind of show it to you. This actually, if you were to FOIL it out, to expand it, ends up giving us what we started with. So this difference of square is almost super easy, as long as you first just check that there is a difference between the two terms and there is a perfect square root. So for example, if this example was this, even though you can take square roots of them, because it doesn't have a different sign, a minus sign in it, you cannot use difference of squares. Or if this was this question, even one of the terms, if you cannot take a square root of, you cannot do this. So both conditions have to be met. So if we try the next one over here, can I take a square root of t squared? Yes. Can I take a square root of 64? Yes. So my two factors will be t plus 8, t minus 8. You'll notice I just wrote plus minus in whichever. Like I said, because this is multiplication, it doesn't matter which one you write first. So no difference whether you write negative first and then positive, or you write positive first and then negative. No difference at all. Again, you can pause this video and see if you can do the rest of these questions, or you can just do them with me at this point. If I take a square root of 25x squared, that gives me 5x, and the square root of 1 is just 1. So I have 5x minus 1, 5x plus 1. The last one over here, again, can I take a square root of 100x squared? Yes, it gives me 10x. Can I take a square root of 81? Yep, that gives me 9. So the answer is 10x minus 9, 10x plus 9. This is my favorite factoring to do, just because it is so easy. Okay, as long as I know how to take square roots of numbers, I can just do this. I don't have to do any big processes. So this is my favorite all time, but it only works if you have difference of squares.